Hello all and welcome back. So from this module, we are going to start a new topic, that is complexity analysis. Till now, we have actually read a lot of algorithms as well as some ways through which we can write our code. We have seen how we can write a code using for loops, defining a function, a lot depth into the OOP concepts, as well as how to use recursion in solving our problems. Now, up till now, whenever we were solving our code, we were always just focusing on the given problem as well as what can be the solution for that. We were not thinking in terms of if the code is optimized enough, or let's say if we have some factor on which we want to change our code or modify our code. We were majorly sure that if we are able to write the code which solves the given problem, then we are fine and we used to move forward. Now going forward from this module onwards, I'm going to explain very nicely to you what complexity is, and any code which we are writing, we have to make sure that we judge the code basis on some complexities. So let's get started. Now before moving forward, I would like to explain what complexity actually is, and this is the definition from Google. So complexity is defined as a factor involved in complicated process or situation. Just like in any complicated process, our code or our algorithm, okay, we have to make sure that we have some factor on which we are judging our code. Now I will explain you with intuitive example as well that why it is required, but first let us see what this factor is. So our main goal is to make sure that the code which we have written, right, we are not going to check its complexity with respect to how hard is it to write or how hard is it to understand or how many words are you using. No, those are not the complexities which we are interested in. We majorly will focus on making sure that our code runs in optimized time and uses optimized space. Now we will be taking them one by one, and first let us talk about time, then we will actually go forward to space. With respect to time, many of you might be having some doubt, the same which I had when I was learning this particular topic, is why are we so much focusing on this time complexity overall? Whenever you would have written some code till now, right, it would have run in maybe a second or hardly, let's say in 1.5 seconds somewhere, right? It was not that you were sitting and waiting for the code to run. Overall, any code which you have written, it used to get completed in a respectable time, something which we used to see. And overall, Jupyter Notebook or any other Python script as well, it used to give that in some milliseconds, it is able to get the result. Well, in the code which we have written till now, those were actually very easy codes. Going forward, especially when we will be making softwares, a combination of such algorithms, such interactions between the code, if there is any bottleneck, if there is any code which is taking a lot of time, or some combination of code which takes a lot of time, that can actually affect a overall experience of our software or platform. To showcase the same, let me show you with an awesome example. So I just have Google in front of us. Okay, so this is Google, the normal Google which we use, and this is my Google, so I'm calling it Moogle. Okay, this is the one which I am like remove something. Now let's say in both of them, in both of these Google, I will just search for recursion. Okay, now this overall page, of course, it gave me the result very fast, right? And you can see one more very beautiful thing, that it is still asking you, did you mean recursion? Now I'm pretty sure you will be able to get this joke. But in my version of Google, let me now try to search recursion and let us see what happens. So I actually have clicked on the searching part and it is taking some time, right? Again, the earlier version of Google, the major version which we all use, that was able to give you the result very quickly, right? That was what your overall expectation was as well. But this particular version of mine, it is taking some time. It is still giving you the result. It is getting you the result, but it is taking the time. Okay. So few changes I have made, just because of which it is basically taking this much time. And you will see that, okay, it is getting us the result. It is still getting us the result. It have been around 10 seconds. Whereas this one was able to get us in a jiffy, right? Hardly more than 1 second. Now both of them are giving me the same results. I'm able to see, okay, it is also asking, did you mean recursion? The definition is there. It is still loading. So there is no difference in what the input I am sending and what the output I am getting. No difference is there. But still, if I ask people to use my version of Google, no one is going to use that, right? And that is where the time complexity of our code actually comes into picture. If one day Google just uses this version instead of the default version which it has, I'm sure it's going to lose to all its customer, right? Any website for that matter, be it Amazon, be it Walmart or any other website, if their code or their platform is not optimized, it's going to be a lot of problem for them to hold their customers, right? I hope with this particular example you get an idea that what complexity actually can have an effect on our code. So that is the major understanding through which we will move forward. So if we have written a code or a solution to a problem, okay, for any particular code or solution which we have written to our problem, we want to figure out how good or bad is it, right? And I've already told that this figuring out will be with respect to time and space. So let me write this down as well. How good or bad with respect to time and space. Now the overall idea is that we don't want that our code or any particular thing which we have written, it just solves a problem. We want that it should solve the problem quick as well, right? And take up less memory. Again, we are going to talk that once we move forward. We didn't like the Google, which was slow, right? We didn't like the overall my implementation of Google just because it was very slow. Yes, it was giving you the same result, but still we will not be using it. In a very similar fashion, many website, many apps, right? You must have seen the Facebook Lite version. Then we have the Android one, which is a light version of Android. They are actually kind of space optimized version of their apps, which can run on low end devices. So that's the reason actually you will see them a lot of places. That's the particular reason. Understanding of this complexity, time and space complexity is important whenever we are learning DSA. These are actually the things which will decide how good of a coder you are and will be a deciding factor when any companies, any tier 1 companies, be it Amazon, Microsoft, Google, or any other product based company would like to hire you. Okay. So I hope with this particular example and introduction, you have a good idea that why this particular thing is important. So in the next class, we are actually going to start with time complexity, which I'm going to explain you with lots of examples so that for any code which you have written, you are able to find the same. Okay. So thank you very much everyone. Let's meet in the next class. Thank you.